Students, good morning students. I'm RBK sir. So ninth standard. So what subject are you taking? Physics. In physics, what are the topics going to discuss now? Work power energy. So the topic is work power energy. So in the work power energy, first of all, we have to just discuss the topic work. First of all, what is the work? So work means generally if you do anything that is called work. So you apply force on anything that is called work. Suppose here in this clip, one boy is standing. So on the table, one box is there. Okay, that boy just lift the box or push the box or lift in upwards or lift in downwards or just you keep the box in once again on the table. So whatever it is, if you do anything, then for that you have to apply certain force. Okay, so whenever if you apply the force, then what happen? It just displays. So work done equal to force into displacement. So if you apply force, then it will displace. Then object will move. So work done equal to product of force and displacement. Work done equal to product of force and displacement. Okay, so work done equal to product of force and displacement. Any other unit is there? Yes. The joule is the unit of work done. That is equal to force unit Newton, displacement unit meter. So 1 Newton meter equal to 1 joule. 1 Newton meter equal to 1 joule. Okay, right. Next clip, we are just going to observe the different forms of energy. Already you know in day-to-day life, for example, we switch on the light, switch on the switch, then a fan will rotate. So in fan, what type of energy is converted? The electrical energy is converted into kinetic energy. For example, electrical energy is converted into kinetic energy in fan. So like this, so many forms of energy in the world. Okay, what are the different forms of energy? First, you have to observe. Okay, the very important energy is kinetic energy, potential energy, chemical energy, okay, heat energy, okay, next light energy, electric energy, like that. Kinetic energy means the movement of the object contains kinetic energy. Potential energy means the object at rest. Chemical energy means crackeries. Heat energy means utensils. Light energy means solar cell. Electric energy means electric light, like that. Here we are just going to discuss the topic detailedly, the kinetic and potential energy only. Kinetic and potential energy only. Okay. So next we are just going to observe the topic kinetic energy. First of all, what is my kinetic energy? Kinetic means movement. Kinetic means actually the word kinetic means movement. So any object which store the energy at the time of movement or motion, that is called kinetic energy. So here the clip is there. Whenever if you observe the definition for kinetic energy, what's the actual definition for kinetic energy? Kinetic means movement. Kinetic is a word derived for movement. So what is the kinetic energy? The kinetic energy is the energy possessed by the body by virtue of its motion. Any object in motion, at the time it is stored some energy, that is called kinetic energy. So at the time of motion of object, any energy is there, that is called kinetic energy. That is called kinetic energy. Okay. Next, any other derivation is there? Yes, definitely some derivation is there and formula is there. First of all, what's the formula for kinetic energy? So kinetic energy generally, we have to refer the formula of m squared. We just prefer the formula of m squared. Suppose any one object has mass m. Imagine mass m which is at A, which is at rest. So if the object has mass m which is at rest, then what is the initial velocity? U equal to 0. Now if we just push the ball of mass m, push the ball of mass m, what happens? It is moving. So after it is moving by pushing, applying force, what happens? It attains velocity, final velocity v. It attains the final velocity v. Okay. So if it attains the final velocity v, how much displacement covered? S is the displacement covered. S is the displacement covered. So after pushing the ball, it attained the final velocity v and attained the displacement S, then it produces acceleration A. Then it produces acceleration A. Then what is the initial velocity U, final velocity V. Next, distance between A and B is S. Acceleration is A. Now, what's the formula for work done? Work done equal to force into displacement. That is W equal to F into S. So, the W equal to F into S means here the work done applied on the object is equal to kinetic energy possessed by the object. இங்கே நம்ம கொடுக்கக்கூடிய work done வந்து kinetic energy மாறுது. So work done equal to force and displacement. So what work done that you given on the object that is converted into kinetic energy. So but W equal to, what's the formula? Kinetic energy equal to force into displacement. According to Newton's second law of motion, you know one formula F equal to ma. Force equal to product of mass and acceleration. Product of mass and acceleration. So substitute the values. So W equal to K equal to ma into S. So kinetic energy equal to formula the force and displacement, that is force on the ma. அப்போ MAS ஆகிடும். இப்போ from the Newton's third law of motion தெரியும், equation of motion, V squared equal to U squared plus 2AS தெரியும். From this you just get the formula V squared minus U squared equal to 2AS. What's the formula for S displacement? V squared minus U squared by 2A. V squared minus U squared by 2A. So displacement is equal to V squared minus U squared by 2A. Now substitute the value of S in this equation. So kinetic energy equal to ma into V squared minus U squared by 2A. AA cancel. AA cancel. Then what's the formula become? F equal to ma into V squared minus U squared by 2A. After substitution, AA cancel. Acceleration cancel. Then what's the formula? M into V squared minus U squared by 2S. V squared minus U squared by 2. V squared minus U squared by 2. Here, initially the object of mass M is at rest. So rest means initial velocity is 0. So initial velocity is 0 means you have to substitute the value of the initial velocity you put 0. Then what happened this formula? So mu squared by 2 is cancel. So only half mu squared we get. So this is the required formula for kinetic energy. This is the required formula for kinetic energy. So what's the formula for kinetic energy? Half mu squared. Kinetic energy equal to half mu squared. V is called a final velocity.